Hello and welcome back to a new video here on the Ludwig Fusel channel. There was a bit of a delay since the last video because I was on holidays and also took a few days to just relax and do stuff for university. But here I am back again and doing new videos in my C++ tutorial series. So welcome back and welcome to a new video. Now today we want to talk about inheritance in C++, or better to say how to extend functionalities of a class. Now to do that we want to create ourselves a new project so that we can start from a fresh section of code. So right click our solution, again add new project. You should probably already know how to do this recently. Now I'm going to give this a name. The name is going to be cats and dogs. Now this name might look a bit odd, but you're going to get what I'm doing here in a second. Alright, as always, we're gonna go into the properties and change a few things. I am gonna go and copy the output directory, make sure this is on all configurations and all platforms, paste this in, hit apply, go back to the other one, copy that one over, paste it in, name that one cats and dogs, and let's put this one on CPP20, hit apply, okay, and we should be ready to go. Now let's add a new item. And let's call that one main.cpp. And let's start coding. We want to include IO stream so that we have a bit more control of our IO streams and we can print stuff. And now what we want to do is a quick hello world to check that everything is working. Now let's set this as a startup project, press F5 and see if we did everything correctly, which we should. And we should see our hello world and everything is good. Project up and working. Alright, so today we wanna talk about inheritance, virtual methods, pure virtual methods, and all the madness that inheritance in C++ brings us. But since this is a quite complicated topic, I do wanna step back and do this a bit more graceful to you and kind of like explain you the problem that we really have. Now, what I want to implement is a pet manager today. I want to implement a pet manager. The idea of the pet manager is that if you are a really animal-friendly person, you probably have multiple pets and you want to have a manager. You want to write yourself a C++ application that manages all your pets and it tracks how old the pets are and tracks like some features of the pets, like how nice they are or whatever you want to do. And for that we need to write classes, of course. So let's start by writing a class for a pet. So we start adding a new file. I'm again today going to implement everything in headers because it's going to be a bit more simpler and easier to follow. So I'm going to create a pet.hpp, or do we also create a cpp file? I don't know. We're going to see if I am in the mood today. Now we want to write a class pet. I don't bother doing namespaces here since this is just a simple example and this project is never going to be used, but you should probably create something like... Oh, actually, I told you that it's good practice to do namespaces. Okay, so I'm going to do them here as well. So let's call this one pet manager as a namespace, and inside we're going to have the class pet. Now we are completely how I would consider good practice. Now, this is the structure of our class, very simple, nothing in here, and now we want to code how our pet goes in. Now, the first thing is, or what I tend to start with, I start to imagine what properties is a pet gonna have. So, what is kind of like the general thing that a pet has, a general thing that every pet exists of. Now, initially, I would find like two properties that every pet would have, and for our purpose today, this is going to serve well. So a pet is going to have a name and the pet is going to have an age. So how are we going to do this? Well, we first need a name. We could do something like const pointer name and then later on point this to a name. Or we could do something like that one, do a char array of certain characters for the name. And everything would be good. We would be able to store the name. However, as I told you, or did I tell you this already, I like to prefix my members here with m underscores or member underscore or my underscore. There's just a bit of convenience that I like to do. There are also people that think on the function, if I have like an int x and they have an int parameter dx, then they kind of like to prefix this with p or pdx for parameter. But I am personally just a guy that uses m underscore and don't use anything at the parameters because it's just obstructing your code. However, I like the M's because they also, if you're on the class M underscore and you're directly, or if you are inside a function M underscore, you are directly greeted with everything that's there. You can directly see what is the name that you're modifying. That's something that I personally think it's good, but I'm not a fan of P underscore or like other, if this would be like a, this is like a C, or there's actually a string, so that's like M string name. I don't like that. I just prefix with M name, everything else should be automatically. Yeah, these are like the two options that we could do. So M name like that and have it like by default, for example, on a null pointer or on an empty string. This would be one thing that you could do. Of course, not like that. Of course, const char pointer. Or you could have an array, but these two solutions have a drawback. The drawback of the solution down here is very simple. We are limited to 255 characters, so if our pet gets a really long name, we're gonna be screwed. And we all need to do all our string memory management on our own. We need to copy the strings with string copy. We need to do string lengths and all the stuff manually. Same thing goes for that. We all need to do the operations manually, but this one doesn't have a also even bigger problem. It's not really storing the string. It is just storing a pointer to the first character of the string, but it's not really managing the string on itself. And the problem here is that the pet is actually a container, and since the pet is a container, it should manage the memory itself. So this is a solution that I would definitely not use if I'm creating a pet. The name should be stored inside the pet. Now, this solution does also have, it's not really fitting here because we are not in C, we are in C++. And the problem here is in general 255 characters, hard-coded. If we use less, if we use less for the name, for example 8 characters, we still use the big memory. If we use more, it's not possible. We need to do all manually, and we in C++, we personally don't like doing everything manually. This is why I'm going to introduce you to a new header today. I'm going to introduce you today to the header string. The header string is basically just a wrapper around a char array. It is doing a bit more things. For example, if the string is under like I think 7 character or 8 including the null terminator, the string is automatically stored in the class, but as soon as it grows bigger, this is 8 characters because 8 characters can also be seen as a pointer, so if a string is like bigger, it's automatically offloading this to the heap, so it's automatically allocating memory, it's automatically managing the memory, it's keeping track of the length of the string, it provides features to analyze the string, to combine strings, and in general, like the class string is a really powerful class that helps us dealing with strings, and really what we can do is we can just use them how we would expect them. Now in C and everything that we have previously done, we were not able to do something like if you have like I would have now a const char pointer argument. I could not do something like M name equals arg. This was something that wouldn't work. It would work, maybe it would work syntactically, but it would not make sense. This is something on strings that wouldn't make sense because they are both pointers and we need to deal with them. Now, since in C++ we have this operator overloading, the class string itself is also managing like these special operators, and you can actually assign strings around if you're using the string class. So that's something that I want to do here. So what I'm going to use is the std string. Now std is a namespace where all of the standard logic is in here, and string is the actual class. I could try and peek this to actually take a look on how this one is implemented, but this is definitely something that we don't understand. You can see this is like a basic string, and I could go deeper like in X string and can find out what the basic string is, which is doing a hell of a lot of stuff with like static assert using. I'm trying to kind of like find a parameter. Const expression is also something that looks like a parameter, but it's really not. Can I find a parameter in here? Probably not, but I would love to show you at least something what's in there. Alright, this doesn't seem... Oh, yeah, there we go. Is that one? Something? No. Now really, I'm not gonna scroll through the string header. You can see it's a rather big header here. But the idea is, I really can't understand what's going on here, but it's gonna make our life easier, and you're gonna see this in a second. Alright, so let's actually implement, oh no, I will forget the another parameter. I actually want to store the age of the pet, age in days. I'm actually going to store the age in days, and by default we are just starting with an age of 0, which basically means that the pet is nearly boring when it's created. Now, when we are creating a class like that, we want to define our big three. I do just set our default constructor here. The other ones are handled automatically by the language. I'm not explicitly setting them to default or deleting them because I just want to have them. I'm just setting the default constructor to be the default one because we're going to have a second one, which is going to take a const std string reference with the name of the pet. Actually, what we could do is we could actually delete this one, which would be equally to just removing it. If we define a custom constructor, the default one is no longer available. We could just do this because, well, a pet without a name really doesn't make a sense. Now, yeah, I said I want to go good practice, so let me go good practice and also put this in the source file. We can try this, create definition in pet.cpp. If we are lucky, see Visual Studio might be able to create the file properly. Yeah, it was. Sometimes it does not, especially if you have a bit more complex project structure. It's not creating this file automatically, then you just need to create this manually. But in this case, it worked. I'm just going to do this here, so we are 100% of what I considered good practice. Now, as you can see, I have given it a const std string reference as a parameter, which basically means that an std string is the object that we want to get, and we want to get a reference to an std string, which means a read-only, or not read-only, but just like the handle to the object, like a pointer to an std string, but a pointer that can't be null. So it's a required argument as an std string, but as a reference, and the reference is const because we basically don't want to modify the name that's given us when we start. We just want to read it and then store it internally. So this is the way to go. There's actually something called std string view. This is something that I would rather recommend using. The problem with std string view is that at some point this might not work as intended, but yeah, maybe I'm going to show this to you as well because we want to do the proper C++. So let's include string view as well, and let's also add the string view here. String view in general solves one particular problem. This problem is that an std string always requires memory allocation. If the string is like there, std string, it's always requiring, if you create one, if you're creating an std string from like a char array. So if I do like my dummy string here and I'm creating this from some text, this is now actually taking a look at this text and copying this into the actual std string dummy. So this std string, it's not a char pointer. It is managing its own memory internally. So it cannot reference a const char pointer floating somewhere in our application. And basically what you would do if you're calling a constructor, so the pet constructor like that. So if you would create a pet like that, so pet Pete, and if you would create Pete like, oh, didn't want it to do this, wanted rather to do that. If I'm constructing Pete like that, this one is stored in the executable, then it is converted into an std string, so memory is allocated, it is copied into the std string, it is passed to the pet itself, and the pet itself is copying it again. If this is a string, I am now kind of like thinking this is a string. So it's kind of like copied into that string here as a parameter. And later on, if I assign this something like name equals name, if I assign this down here, then it will be copied again. So what you would really end up is with two instances of an std string. One std string which is kept constant as a parameter, and one std string copied in here. These std strings might actually be optimized away by the compiler, but we cannot really be sure. The difference of an std string view is actually that it is just like a view to a string. This view to a string just needs to conform to any string. So actually, if you're adding a pointer into a string view, it is kind of like just storing the pointer. If you're adding an std string, it's kind of like storing the reference to the std string. So really what it does, it is kind of like an alias of, hey, give me any string or possible. Every normal string that you can do. If it's a normal pointer, if it is an std string, you can just input every string here, and it's automatically kept into that string view. And what we can use here down here, you can see that I still can assign the string view to a normal std string, because the std string is actually designed to handle these. The std string is programmed, is written to handle that, so it needs to handle that, and it automatically converts it and then copies the data over. The only thing that really happens is that you don't need to always create an std string as for the parameter. The parameter can still be a normal char pointer if you're doing a string view, or it can be, yeah, again, it can be really everything. It's just a bit of a smarter way of doing this. This can give you some headaches. For example, if you would use an std string stream, I don't think that it's included here, but if I would include this here, I'm not quite sure if the string stream supports string views. It might do. Does it support them? Yeah, it supports them. But what it definitely does not do anything that takes a... I don't know why I'm today a bit bad at writing const char pointer, but again, you could not convert this like that. That doesn't work. That is something that doesn't work. So every function in the world that takes a normal string, like a const char pointer, cannot handle a string view. Now, could you convert this one? No, you cannot. There is kind of like a data here. There is a data function to access the data of the string. However, this function is not guaranteed to contain the string with a proper null terminator and everything. Also, like everything here, like substring, empty size, these are all functions that might work. I think substring is actually working quite well because it's converting this to a proper string. No, it's again converting this to a string view. However, you need to be careful with these string views. You should use these string views never to use a normal const char pointer. You should be a bit aware when you use them, because they can break if they have a certain way of they are called. So in general, use them as parameters that are then like converted into a string internally in the class, and then in the class just continue on working with your name here. All right, so this is actually the way that we need to do. This is the constructor. This is exactly how we do it. We don't need to do anything more. And yeah, that would be totally fine. Now, we would have one issue with that code here, or not one issue, but I have one issue. I have the issue that it's initialized like that. And if you are initializing this like that, that means actually that first the std string constructor is called with no parameter, and later on the assign operator is called with the actual string view. So actually what you're doing is you're calling two functions on that m name to create this. You're calling the default constructor of that std string, which creates an empty string, and you are calling the assign operator. You can actually boil this down to just calling the constructor with the string view, but you need to do it differently. You can see that currently this is like in the body of the function, so all of the members of that class are already constructed when we are entering the code section here. As you can see, if we are calling that function here, the first thing that happens is that the compiler initializes these members here. So it takes a look and sets the name, it takes a look and sets the age, and then it enters this code section and executes this code section. And what we want to do is basically we want to bypass this default construction. You could do this by adding arguments here so that you would have a default argument and yeah, everything would be good. But we don't want to do this. This is dynamic. We don't gonna write some static thing in here. It doesn't mean that really this needs dynamic. You can also have like a function call in here that's called for initialization if it's a static function. That works. However, it's still like bound to that one function. It's not a dynamic parameter. But we can actually do this. We can actually do this by writing a colon here, and this colon means now I want to initialize my members. Now what I can do is I can give it a list of all of my members that I want to initialize. I'm going to do this by giving it the name, and normally you would think, yeah, maybe you are then doing something like equals, and then like semicolon, and then would like continue with the age, but no, this doesn't work like that. Actually, what you're going to do is you're going to try to call a function on this. This is not really calling a function, this is kind of like calling the constructor, because you're kind of like saying, okay, this is my member and I call the constructor. This is kind of like how you would do this. For example, if you would initialize a pet, you would do this with, or let's do this with the string example, string, you would initialize this with that and give it some arguments. And this is kind of like what happens here. This is like the syntax that's going on here. The type is already defined in the header, so you don't need to rewrite that one here again. And what you can basically do here, you can see that this is already totally fine because it carries a default constructor. And what you can do is you can add the name in here, which means that we don't need it down there. And this would now call the constructor with a string view, which means that we just have one constructor call, no operator calls, and everything is initialized correctly. If you want to initialize more variables, you're going to write not a semicolon, you're going to write a comma, and then you can continue on, for example, with the age of days and set it to 0. However, we don't need this because this is already initialized to 0. And actually, the compiler is going to be smart enough. The compiler is going to see that this constructor initialized the name already, so what it's going to do is just going to initialize that one. It's going to skip the name because the name has already been initialized here. And if you write your code like that, you can simply create a pet based on this name. I know, yeah, these are probably, again, the most explained, like 2 lines of code that I have written. Okay, now really it's like 1, 2, 3, 4 lines of code if you really would go for that. But yeah, we talked about strings and string views, which is like how many YouTubers would probably do like their own video for that. But I personally hate the idea of doing too many videos, which is maybe bad because would probably be able to do a full video about them, but I do want to try to introduce all these standard things gracefully while we are doing other stuff, which I hope you're fine with, but yeah, that's the idea. Alright, so this creates ourselves a pet. So let's actually try this out. First of all, we're going to close all the other gunk that we don't need. And then we're going to quickly include our little friend pet. And what I want to do is I want to now create a pet. So I am actually, I'm not going to using the namespace. I'm going to do is using namespace here, using namespace pet manager so that we have access to them. This basically allows us to use the pet like that and does not require us to do like a full pet manager pet here, which is just giving us a few more flexibilities here. All right, so let's create a few pets. I want to create a pet Tabby, and Tabby's name is going to be Tabby. Then I'm going to create the pet Oscar, and its name is going to be Oscar. Or maybe we're going to capitalize the name here so that we have Tabby and Oscar. Now we can do like an Eve. We can do Eve here because, or you can do this like that. However, there's some oddness of C++ that this works, but really what it does not work. If you would do this like pet like that, it doesn't work. If you do it like that, it doesn't work. Somehow it is fine with that. I don't think that it hits, that it can compile. It might compile actually. Yeah, it does compile, but it's not really prototype function not called was a variable definition intended. Yeah, this is like a warning. It's not really. It's like, yeah, trying to do some odd stuff. So in general, if you don't have parameters, just do it like that, or do it like that, or things are gonna break. But again, as you can see, we can't create an Eve because Eve would need to get the name Eve to exist in the world. All right, so now you can see that everything works, and we could press F5, and we would have a nice Tabby, and we would have a nice Oscar that don't do anything. All right, so yeah, let's add a few more features to the pet. First of all, we have that age, and I want to have a bit access to that age. First of all, I do want to have a void age, the void age function, or the name is a bit odd, but I'm just going to call it age, and this will basically age the pet. Or aging, or day pass. I know how I want to call this really, but I could. We're gonna be quite cruel. We're gonna create two functions: lived and died. We're gonna have two functions: live and died, because I'm gonna be funny today, and we're gonna have a living attribute, which is by default true, because when the pet is born, it's living, and you can then on each day call like lived, which increments the days, and die if it died. So yeah, this sounds a bit cruel what I'm doing here, but that's just the reality here. Let me quickly include std except here to also catch a few errors that could happen. What I basically want to do is if living, I do want to say age and days plus, but I do violate my own rules that I don't. Age and days, I can increment this, or actually better to say I want to say if not living, and then I want to increment, and if they're not living, I want to throw in a city logic error. A pet that already died can't live now. Can't live again. So something like that. So if we have anything, we're gonna get the error. If we are dying, we are basically just set living to false. We could also check this as well and say, all right, if it's already died, we can't call die, but I'm just gonna overgo this one here. So yeah. I do want to have a few access to these variables, and I want to do this by getting the name. I do want to get a actually, I want to get a const std string reference for getting the name, get name, something like that. I do want to get a bool, get living, and I do want to get a size t, get age. Now, all of these are going to be const, and get living is also going to be no except, and this one is also going to be no except. Actually, this name one, we can also no except these because the retrieving of the name is not going to fail. However, modifying and using that name might fail. Now, since these are simple getters that are really just going to get one line of codes, I would really recommend writing them directly in the header and just saying am return name. And then I also would flag them here as inline, which allows the compiler to remove that function basically. Basically what it is allowing that is it basically allows read access directly to that object without calling a function. Calling a function means calling a call instruction, instruction, which means pushing something to the stack, which means jumping to that address, which means executing at this address. And the call basically of calling a function has an overhead. So having inline in here indicates the compiler that this function might be inlined and makes it more likely that the compiler inlines it. But really, the keyword is optional. We already talked about this. But I would recommend writing your code like that. So we're going to do this here for the other ones as well. Living and ancient days. And what I then want to do is that. Now, this one is not it's a bad one in here that's screwing us up, but if we remove it, everything looks good. And the pad has a few things that we can do with it. Now, let's play a bit around with my pads, and yeah, let's get talking. All right, first of all, I want to age a few pets. How do I want to age my pets? Well, let's call them. Yeah, how do we gonna call them? I think like I really don't want to kill my pets. Do I kill them? No, I probably need to kill them at some point. Or do I need to kill them? No, I don't really want to kill them. Do I want to kill them? Yeah, I know. I really hate killing pets, so maybe I not do this, but maybe we need to do it. But now if I kill like the Tabby or the Oscar, it means like if I kill the cat, I'm a dog person. If I kill the dog, I'm a cat person. Or is it like that? Or maybe I'm a cat and a dog person, so maybe you didn't know if I kill one, but maybe I do more likely kill like a cat because I have a dog, or maybe I rather kill the cat. Or maybe I shouldn't talk like that on YouTube because it's probably not good for the algorithm, and it thinks that I'm doing bad things, but like this is just all virtual. Maybe it's not the best example. Maybe I should have used cars and disposed them or sell them so that they're no longer in my possession. But yeah, maybe we're gonna. Do we want to sell pets? Yeah, because we are a pet shop. But I already talked to that. But it looks so cruel. Like yeah. But maybe I should just do programming. Yeah, we are. The word is cruel. So yeah, we're gonna do this. Okay. So now let's age them. First of all, Tabby lived, and then Oscar lived, and this continued for like 3 days, and then at that day, Oscar died. And then only Tabby lived. That's the section of of events that gonna happen. And since I do actually like both dogs, both animals would have died at a point. But there's actually now the cat can't die because I need this for the actual output of the cat. Because as you can see now, I can modify my cats and dogs how I want, but it really doesn't give me any feedback. I need to print them. How can we print them? Let's try printing a Tabby. And let's try to print a Oscar. And you can see it really doesn't work. We need to implement the operator again. So let's go to pet.hpp and let's do a inline. Well, actually, we do not actually need to inline them. We can just do a... We need to first of all include our OStream, and then we can do a std OStream. No, come on. Why is it screwing me up today? I don't know. OStream reference, operator left shift, std OStream reference OS, and the const pet reference pet. And then we wanna... No, because this is a pet manager pet, like that. And then we can implement that one in the... What the hell is that? Throw GC new system not... Okay, this is some really odd code that Microsoft tried to give me. But really what we want to do is we want to return OS, and what we want to do is we want to say something. What do we want to say? First we're going to say the name of the pet, get name, yeah, like that, get name, and then we want to say like the living... pet is actually this should not be called get living, because get living doesn't make sense. There should be something like is living. Like is and get, it's always like how you want to do this, but is living makes more sense than get living, even through like getting variables. Hey, it's also some philosophy question, right? So yeah, let's get the age here and then talk about philosophy questions, because yeah, they just take away time. Okay, so I'm just gonna do a simple pet print like that. And yeah, that's how I want to print a pet, which should work now in main. And now if I run this, I should get an Oscar, which is 3 days old, and a Tabby, which is 5 days old, and Oscar is actually not living. And actually what we can do is we could do this a bit nicer. Actually, I do not like how I do this. I do just want to do it like that. So is living question mark, and depending if we are living, we are doing something. This actually does not work, the syntax. To make the syntax work, you actually need to put brackets around this. And what now basically happens, if is living is true, the first expression is evaluated, and if it's false, the second one is evaluated. This expression is especially powerful if you're using this like in streams like that, but we need to add brackets around or it will not work. And you can see something like living or dead. And now if we would do this, we would get proper output. Living at age 5. Actually, maybe I do want to have this the other way around. Yeah, I know I'm really picky. But I like my syntax as I like it. And this is something where we can put the age in here, and then we want to put like a space in here, and then we want to put this living here. So now we have like the age and then like living that. Okay, so the Tabby of age 5, which is living, or the Oscar of age 3, that is dead. And yeah, now we are sad, and we're gonna all pray for Oscar. Maybe, yeah, no, I'm not gonna be as cruel and say pray for Oscar, because, yeah. Maybe we're gonna do it, yeah. Well, maybe we are C++ guys. Oscar could change his name, so really, we are not very personal here. So what we actually say is, we say Oscar get name, because we don't know if Oscar ever gets renamed. So we say rip get Oscar get name instead of actually hardcoding the name, right? This is like how to not hardcode, right? Rip Oscar and not rip Oscar in text, even though this is longer and looks uglier. But yeah, it's like the point here to not hardcode stuff, and maybe add endlines. This is like good conventions to add them. Even though in this case an endline is probably more like adding us a new line there, but in some certain senses especially, yeah, just keep the new line here, and I always like to have everything new lined on my code base. Alright, so now you can see we have written Tabby and Oscar, and we have a sad story about Oscar. Maybe we could also print this one. Sad story about... Yeah, and you know me, get name. Like that. Come on. There we go. And I know that I'm just adding random code, but it's just fun and a bit sarcastic, this code section. But yeah, I had enough pets to be allowed to do such jokes, so yeah. Okay, so this is like the code here that we have, and I want you to spot the biggest mistake that I have made by writing this pet manager. Which is really not managing anything, but you get the point. What is the big mistake? Well, I'm gonna solve it for you in 3, 2, 1. We don't know what pets are. Pets is not a thing. A pet is just like a group of potential candidates. A pet could be a cat, a pet could be a dog, and obviously it's like an Oscar could also be a cat, but I already spoiled that Oscar's a dog, but yeah, Oscar's a dog and Tabby is a cat, but really you can't tell, right? You could call your dog Tabby, and you could call your cat Oscar, even though I think that like Oscar is more like a dog name, or actually it's not. Paddy would be a good name, but this would be let's call him Paddy. No, I'm gonna get issues with one big YouTuber. He probably never sees my videos, but if he finds out that I killed Paddy, no, that's not a thing that I can do. But yeah, really, like Oscar is for me, it's a dog name. And Tabby is for me a cat name, but really you could think that Oscar's a cat, both are the cats, both are dogs, you can't really tell. Because it's just a pet. A pet is not a thing, and we need to solve this. How could we solve if this is a cat or a dog? Well, we could solve this by adding a new parameter. We could add something like std string mKind, and in kind we're then gonna write dog, or we gonna write cat, and this is now pseudocode of course, but we could write dog or cat in here. Right? And we could add this as a parameter while constructing, and everything would be good. Or would it be? No, it would actually not be, because dogs have different parameters than cat. Cat, for example, are from its nature like a single. I would like say single person introverted. No, but really, like from the nature, a cat lives alone. and from the nature of a dog, he lives in a pack. Or a dog, you can train dogs some stuff. You can train a dog several acts that he could do. You could also try to teach a cat acting and let it act something, but it's not in the nature of a cat to do that. The cat can do this, and the cat is rather training you than you are training the cat, but the cat could do it, but the cat doesn't want to do it. And if you have a cat that really loves you, you might be able to train the cat something, which works in a certain extent. And if you're lucky, you can train your cat more stuff. And yeah, go to the circus and you can see cats and dogs doing stuff. But that's not the point, right? But for example, if I would say I want to implement that the dog can learn something while a cat can learn you something, like the relation. The dog can give you, the cat can give you commands and you can give the dog commands, something like that. And this is something that I would not be able to implement now, because now I would need to implement both behaviors in the pet to support this one for dogs and cats. And that's not really the point, because if I implement both behaviors, it's going to get a mess. If I am going to implement each behavior for a fish, or for example a fish might have a swimming speed, while a dog has a running speed, and the cat also has a running speed, but the fish does not have a running speed. So yeah, really that's not a good idea to put everything into one little class. So the idea here is to actually create classes for a dog or a cat. Now, how could we do this? Well, we could just start and go on with the end. Now you see what I'm doing, cat.hpp. And write some class for the cat here. So namespace, pet, and actually Visual Studio, come on, does not suggest me the namespace. Okay, pet manager, and what we then would do, we would of course include the pet itself. So let's include the pet here. And let's do something like class pet, class cat, and then we could do like public and private. And we could then, for example, in the cat, start a pet and say pet or pet data, and we would have all the data for the pet in here. We could write a constructor with like the const std string view reference name, and we could say something like my pet. I'm just gonna write this in the header quickly. Pet data. Come on, why do you not like this? It's going to be the name. Of course, you don't like this because of that. And then you could pass on the pet data and you have a cat, right? Now, what would happen if I try to use the cat? I can include this and I can try to make Tabby a cat and everything works, but that one does not. Obviously, it doesn't work because now the object is a cat. The type of the object is a cat. The cat somehow has the pet stored. Okay, so we could do something like inline cat reference, pet reference get pet, and then do something like return pet data here to give access to the pet. And then I could say something like, okay, so Tabby pet, get pet, Tabby get pet lived. Something like that would work. Or here, Tabby get pet, and I'm able to print it again. However, this is not a good syntax, as you can see. It's involving so many code. And for example, if you are now having like a Maine Coon cat that is based on a cat, you would then have like them on the Maine Coon, get cat, get pet to get all to the data. And that's not a good idea. And this is why in C++ we can actually extend the class. So basically what we can do is we can take the pet class and say, all right, on top of the pet class, I want to build another class called cat. And we can do this by basically specifying which classes we want to extend in that class. So we have a base class, it's a pet, and we're going to extend this in the cat class and specialize it even more. Now this is called like inheritance because we are inheriting from the class pet. And how are we going to do this? Well, we're going to specify a double point, and then we're going to specify an access modifier. We could, for example, say private pet. This would now say that the cat is a private pet. How would we do this? Well, first of all, we remove the pet data and all that stuff down here because the cat now is a pet. However, you can see that initialization here doesn't work, but we still need to pass the parameters onto the pet. How are we going to do this? Well, we're just going to take the name of that superclass, which is in this case a pet, and we can just pass on the parameter here, which is the name, to that pet, and now we have a cat that is a pet. However, you can see that this still doesn't solve the problem. Well, it doesn't solve the problem because the cat is a private pet, and private means, well, the pet is only visible internally. So if you're doing this privately, the pet it's going to only be accessible from within that class. If you want to expose this, you need to make it public, which basically means, hey, this is a cat, and the cat should publicly also behave like a pet, which basically makes all the pet's properties, all the functions, all the members that may be public, everything that you can do with a pet, you can now do this with a cat. And if I go back to my main.cpp, you can see everything looks good, and we have a cat. Now, there's still one thing that I don't like. You can see that we still need to duplicate our constructor, which means if we are adding parameter to the pet, we need to add parameters to the cat as well, which is not ideal because it just involves writing many code. But there's also a way around this in C++. We can actually tell it to use the constructor from the pet and basically say, all right, the cat does not specify any more specific arguments. You're just going to use the default constructor from a pet. We just extend this. And we need to do this by basically indicating what functions we want to use from the pet. And we're just going to say this by saying using. We all previously used the namespace. Now we are using a function pet, which is basically saying it's the class here, this is the class pet, we want to use something from the pet, and what we want to use from the pet is the constructor, which is down here, and this now allows us to use all constructors that we would normally use on the pet for the cat. And if you take a look at this now in main.cpp, it's still nothing changed. Everything's still working, but our cat is way more cleaner. We don't have code duplication, and if we run it, should still have the same result, which is not what we want actually. We have the tabby, the Oscar, but we still don't know what they are. Like in code, yeah, we can tell. It's a cat, but what is Oscar? A dog, whatever. I know. Let's start with the cat and try to find out how we can actually add the the kind of pet that the tabby is. Well, we're going to do this by writing a function inside the pet. Now, normally what you could say maybe is you could say, all right, I want to have a custom overload for the stream operator here. This would be possible. You could actually go in and say, all right, this is going to be a custom function. Would work, but that's not really what I want to do. What I want to do is I want to write a special function inside here that allows us to get the kind of the pet. So what I want to write is I want to write a std, actually, yeah, let's just, I think we don't need to make this one const because a string view is already const because it's a view to that string. So we just want to actually return not a reference, just a string view. And we want to call this one get kind to get the kind of the pet, which is should be const no except to doesn't put in any cost. And what we can do is we can add a default implementation and return something like pet, which is automatically converted to a string view, and we can access it. Now that we have the function available, we can go down to our pet.cpp and we could say we want to first print the kind. Then we have like cat, then we maybe want to have the name in quotation marks, and we have like cat, no, I forgot the stream here, cat, and then in question mark there as well, I'm an idiot, cat, and then another quotation mark here, and have it like cat tabby. And if we do this, it should be quite good. And if we run it, we should still see no result, but we should have a bit of infrastructure. Now, pet tabby, pet Oscar, and still the same parameters. Okay, so now the only thing left to do is now to change that pet to become the actual cat and dog. Now, we can currently just do this on the cat because we don't have a dog yet, but you should get the point on the cat as well. Now, the most simple thing you would think that we can do is basically copying this function, right? You would be able to just go to the pet here, to the cat, and paste that code in here instead of pet. I'm just going to write cat, right? Would this work? Maybe. And if I do this, we can actually see that we still be at pet tabby pet Oscar. Now, you can see it does not work. However, I can show you when it works. Actually, if I take the tabby and I call get kind on the tabby, and I'm going to print that one down here. So stdc out the tabbies, there we go. And if I would just print like tabbies, I know this is bad syntax, but this is going to go after pressing F5. If I just write tabbies get kind, you can actually see that the tabby is a cat. However, down here, tabby is no longer a cat. Why? How can it be that the tabby is a cat above here and it is a pet down there? Well, it is because of the types. If we are getting kind here, you can see that we are calling this get kind on tabby, and tabby is an object of the type cat. However, when we are couting this with the stream operator, you can see in the pet.cpp that this here is no longer a cat. This is now a reference to a pet, and since this is a reference to a pet, the stream operator is not aware that it is a cat because, well, it's a reference to a pet. And if you're referencing a pet, it's going to call the getKind function with the pet and not with the cat, even though it's the same object. But these functions, they are just returning a string, just a normal string. And the normal string is going to contain some data. And the thing is actually that this function, it's not bound to the object itself. It really doesn't care. It's just a like static, hey, return a pointer to that location with the string view. And this is why it's dependent on the type that we have. And we need to overcome this. Can we overcome this? Of course we can. We can do this by basically marking this function with a special keyword, which tells the compiler that this function is going to change. Now, this keyword basically means, all right, don't really access this function directly. Normally, functions, they are just accessed by calling that function. The compiler knows where it has put the function. Actually, the linker knows where it has put that function. And when you call it, it's just jumping to that function and it's executing there. And so it's dependent on the type. If you have this on the pet, the compiler is all right, you're calling this function on a pet, so this needs to be linked to the function of the pet. If you call it on a cat, it's linked to the function of the cat. And this is the thing that we need to overcome. How can we overcome this? Well, we can overcome this by not calling the function directly, but rather like checking where the function is stored. So instead of directly calling a function at a static position, we want to call like a function address, a so-called function pointer. What we want to do is we want to kind of like store a function pointer in each instance that is like pointing to the right implementation of getKind depending on the type. And actually, this is all done automatically. Normally in C or any other language, you need to implement all these mechanisms by your own, but in C++ it's done automatically. There is something called the virtual method table. This is actually a table which is created with each object that has some kind of these functions, some kinds of functions that need to be resolved dynamically. It's like a vtable, it's called, virtual pointer table, however you want to call this, virtual function method table. Methods really are methods, so virtual methods table is like, I think, the proper term. And what's really happening behind the scenes is that you basically have a table somewhere with your object stored, and if you're calling then getKind, it's basically just taking in a look inside of the table at a certain offset, and it's going to take a look at, all right, where is the real implementation of that function, and it's going to call that one. And this is like, it's all very complicated, but the idea is really just to prefix this function with the keyword virtual. And if you're prefixing this with the keyword virtual and running that, even though we are not at a 100% clean syntax, where we are going to get in a second, you can actually see that now Tabby down here is a cat as well. If you want to inspect this a bit more in detail, we could make a breakpoint here, or really somewhere else in our code, and actually take a look at this. You can actually see that the Tabby is a pet manager pet, and you can see that this pet manager pet now, additionally to our name, living, and the age and days, has this parameter underscore VFPTR, which is like virtual function pointer. And if we expand this, you can actually see that this is an array. And in this array, you can see that we have certain elements. Currently, we have just one virtual function, so we just have one. And you can see that at its index 0, you can see that this one is pointed to cats and docs.exe, pet manager cat getKind. And if you would take a look at the Oscar at the virtual function pointer table, you can actually see that this one is pointing to the pet manager pet getKind. So here's the pet, there is the cat. And this basically means that no matter of which type we are giving it or which type we are calling the getKind function, it's always taking a look at this table and then jumping to the right function and calling that. And this is fine. So you can see now it's working. But there's still one thing that I don't like. And what I personally don't like is that you don't see what's going on here. Now, actually, what there is a keyword that you can specify which explicitly states that this is like implementing a virtual function. And you're going to do this by adding the keyword override. This is just some syntactical sugar that you can actually see what's going on here. So const no except override. It's a constant function. It is a non-except, and it's overwriting the function from the superclass, parent class, base class, however you want to call this. And this really doesn't change anything on the behavior of the code, but it's making this look way better. And yeah, it's a bit cleaner here. Now, actually, this is still having one major problem, our code. And I want to indicate here what the problem is. And I'm going to do this by, first of all, let me go to the pet.hpp and let me write a destructor. So what I want to do here is I want to write a destructor. And in this destructor, I want to stdc out, which is probably not going to work because I haven't included this one yet. IO stream here, there we go. And what I want to do here is I want to say destroying pet. And yeah, that's it. And really what I want to do here now as well on the cat is I want to do the same thing, but now I want to do this with the cat, and I want to say destroying cat. And maybe I should add some end lines that this looks a bit nicer, so I can see what's going on there. And I'm going to add this in here as well. So what we really can see here is that we have two destructors. Now, the behavior that we're going to see now on the stack here is going to be probably as expected. Let's see. No, this is not what we expected, but just press F5 again. This should solve the issue. And everything is good. This com.error, I don't know where it's coming from, but sometimes it comes, just recompile and everything's gonna be fine. You can see that this now is actually working. It's destroying a pet, which is the Oscar, and after that it's destroying a cat and a pet, which is the Tabby, because a Tabby is a cat and a pet, so it called both constructors. And this is exactly the behavior that we want to see. We want to always see all destructors called, and also in that order. The Oscar was called first because he was down there, so Oscar was destroyed first, so this is one for the Oscar, and this is for the Tabby, and the order is cat and then pet, because cat is the most top level class. We are instantiating a cat, so the cat's destructor is called first, and then we are calling the pet's destructor, which is the exact order that we want to have, because if we allocate some memory in the pet, it needs to be freed, no matter what cat in the destructor does. Pet maybe has a void pointer in here, which is pointing to some arbitrary memory that is not viewable by the cat and is not accessible by the cat and just internally on the pet. So the pet needs to have an option to actually destroy this. And the same goes for the cat. The cat can have the same thing, and everything else in the chain can have something like that. And it's important that both of them are called because of memory management and more things. And yeah, so everything is good, you think. But actually, I can break this. Let me do something like that. Let me create a pet pointer PT, and let's assign this to a new cat that is called Eve, because it's an evil cat. Now, what you can see what's going on here is that we are creating a cat. However, we are assigning a cat to a pet pointer. This actually works, and this works because a cat is also a pet. This would also work with references. If you would do this with references and like dereference that, this would work as well. Because a cat is a pet. You should not do this because you lose the pointer, but you get the point, this would work. Other way around actually does not work. I cannot do a cat pointer based on a pet pointer. This does not work. If you want to do something like that, you need to call some odd thing called dynamic cast and say that you want to cast this one to a cat pointer. And this is now actually dynamically checking if the pet is really a cat. This is done with something called runtime type information, RTTI, which is basically, hey, type, are you a cat? Yes, you are a cat. Okay, I can convert this. If you are not a cat, I cannot convert this. That's really the idea that's happening here. This works that way around, but this may be something that we're going to explore a bit in the future as well. Dynamic cast, it's looking a bit odd, but it's just how you use it. It's the only like C++ style cast that I use. You could also do something like that. You could also try to C-style cast this to a cat, which would also work. But if you would try to do this with a dog, we don't have the dog here yet, but if you would do this later on with a dog, the cast would succeed and the cat pointer would have some value, but it would not be a cat. And dynamic cast returns a null pointer if the given pet pointer is not a cat. That's the difference here. Going the other way around from the like super specialized cat class to the pet is always not a problem. We already saw this actually happening down here in the stream operator. I didn't really go into detail there, but like the idea here was as well. This is a reference to a pet, and the cat is also a pet, so I can convert this to a reference. And the other way around, it doesn't work. But if I would do this now like that, and now I would delete the PT, we're gonna see some interesting things happen. Let's make a breakpoint here, and let's run this. Now, actually, if I take a look at the console here, you can see that we are now only destroying a pet. And we are only destroying a pet, well, because we are deleting a pet. And if we are deleting a pet, the compiler really doesn't care. It's just calling the destructor for the pet and freeing the memory. And bad things happen, because again, a pet is not a cat, but a cat is a pet. Get the point, right? And if I delete just the pet, it's bad. But it could be that you have a container that is managing a lot of pet pointers, and it doesn't care what's created one. So a new cat was created and it was stored somewhere else as a pet, and the pet is later on deleted, which is probably how you would do this in a pet manager like that. And there you can see that we have an issue because a destructor of the cat is never called. And you already probably know the solution to that problem. Yeah, make the destructor virtual. Because if we are making this virtual, it's going to go into this virtual table, and now everything is good. and we should have the proper constructor order called. And if we take a look at the console now, we are destroying the cat, and we're destroying the pet, and we are good again. And that's like the whole idea why I have implemented that one. However, as you can see on the cat and the pet, we don't really need a destructor, but we can get rid of these. You can actually delete this one and assign this to the default implementation. This basically means, hey, I don't need a destructor, but make it virtual because, yeah, we're going to extend that class with the implementation, for example, for the cat. And on the cat itself, we can just remove it completely. And as soon as your like most basic class is implementing the virtual constructor, virtual destructor, everything is good. Virtual destructors, it's always something that you should do. You could add this one as well, I think, but you really don't need to do it. Like, this is now how you would create a cat. Now, of course, since we are loving cats and dogs equally, even though like this was a heavy cat example here, I do actually want to create a new dog as well, so that the only dog persons are happy as well. So let's create a dog, which is really just a glorified copy-paste version of a cat, right? Should not say that. But yeah, now we have a dog as well, and yeah, later on you would add proper properties to them as well, but I don't bother now. And now we can actually make this one a dog. And now to show this here with dynamic casting again, let's make a... Oh no, no. This is definitely not how things work out. This is how things work out. Now let's maybe do a pet pointer TP. Pet pointer, tabby pointer equals to pointer to tabby, and a pet pointer Oscar pointer equals a pointer to... do we need an Oscar? We actually now... We already talked so much about cats. Let's not talk about dogs. A Oscar pointer to Oscar. And now if you would try to cast them, for example, to a cat pointer, CB... cat, cast back cat, and you use this dynamic cast for a cat, and you try to cast Oscar to a pet, and you try to cast Oscar to a dog, or not Oscar in this case, but really it is Oscar, but yeah, get the point. You're gonna actually see that this dynamic cast here is gonna return null pointer for the cat and a proper pointer for the dog, because the cat is not the pet here, which is a dog, is not a cat, but it's a dog, of course, here. This is like how the idea here works. I could again show this to you how this would work with like C-style casts. If you would C-style cast that one, let's make this one here with that little alt drag because it works nicely here. And I would try to C-style cast this stuff around. You can actually see that it is working. You can actually see that both pointers now are populated, and it really doesn't matter because we don't have any like special parameters in the dog. And yeah, actually you can see that something goes wrong because the cat is already looking a bit odd. You can see like the dog, it's looking correctly from the hierarchy. It's a dog with no parameters, and then it's a pet. However, like the cat, you can see really that it's like also a pet, but you can also see that it's like a dog and it's a pet. And really you can see that some things are not working out how we did this with the cat, because the compiler is actually a bit smarter, or not the compiler, but the debugger is a bit smarter than what we have C-style casted there. But yeah, that's not the point here. Alright, so that is like the idea of that. Let me actually remove all of that because that's not required. And yeah, that's it today about that. A bit longer video. Maybe I should have split it, but I was away such a long time. So maybe a long video isn't that bad. So hey, here I am back again with a long video after like I think like 10 or 11 days without no videos in this series, which is really bad and not how I intended it to be. I hope I can keep it up because I have had a lot of stuff for university to do now the next weeks, but we're gonna see. And also like founding the company for the YouTube channel and stuff. This is like all things that I have on my desk now because I was too lazy to do it. And as always, when the new year comes, you're gonna make a list of things that you want to get done in the new year and you want to get for the new year and things you want to make better. And founding the company is on that list. And it's now getting real. That's the thing. I started this also previously, but now it's getting real. So thank you for watching. See you in the next video. If you enjoyed, make sure to like and subscribe. And if you're not enjoyed, of course, write a comment and say what I did wrong. But you're probably gonna enjoy it, right? I don't know. But it's okay to not enjoy it. It's a long video, and no, people tend to not like them. So yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.